So here's our activity for today. We're going to talk about something called position in the data set. Now, the reason why we're looking at position is because sometimes we do really well on a test and we want to see how we did in comparison to everyone else. And not just exams, there's a lot of different data sets and we want to know where do we stand in comparison to the rest of the data. Let's start with the first question. One of the positions we've looked at is the mean as well as outliers. So let's go ahead and use our groups to fill in the rest of the sentence for number 1. Now, for the most part, most of the data is going to fall where in the data set? Well, okay, so the answer is close to the mean. Yes, that is true. So we can immediately write close to. But what I want to explain here is that, why is it close? Where's most of the data? It's going to be in the middle. And where is the mean? In the middle. So most of the data falls around the mean because most of the data and the mean are in the middle. So that's why the first one was close to. And outliers, we already know this one is going to be good, far away from. So that's an example of 2 different types of positions, both the mean and outliers. But we're going to look at even more positions today. In the second one, we have to sort of review what are the mean and standard deviation. What does this symbol over here mean? Mu. Mu, and that stands for the mean. Good. So we have a mean of 71, we have a mean of 74. So that means one of these graphs has a mean of 71 and the other one has a mean of 74. And then what does this little symbol mean? Sigma. Does it have anything to do with the sum sigma? No, completely different symbol. And what does this one mean? Good, standard deviation. So again, one of these graphs has a standard deviation of 13 and one of them has a standard deviation of 14. So let's see if we can sort of guess which one has the mean of 71 and which one has the one of 74. Same thing with the 13 and 14, and put them on these graphs. And these graphs come from previous test data. So again, we can work in our groups.
And this one has more greater value, so that would have the higher mean.
You know, I can't tell you which role this is. I can't say. I've been at a community college.
I guess this one's more spread out into valleys, so this one would be more significant.
What should you guys say? Is that because
this outlier, this
Okay, let's discuss. Let's start with the standard deviation. What does it mean when you have a smaller standard deviation? The data is closer. Which one has a closer test score? Is test 1 or test 2? Test 1. So test 1 is going to have the smaller standard deviation. So this one has to be sigma equals 13. I'm going to change this back to red. So this is going to be the sigma. Oh, sorry.
my bad. This one has the smaller test scores, so sigma,
smaller standard deviation because the test scores are closer together. And likewise,
this one has to have the bigger standard deviation. Okay, what about the mean?
which one do we think has the higher mean? Test 1 or test 2?
Just one.
Why test 1?
It doesn't have an outlier.
Good. So test 1, we see that on average, the test scores are higher. There's not an outlier down here. This one has an outlier that makes the test scores lower. This one has the higher test scores. So this one
It's going to have a mean of 74. And this one has to have a mean of 71. So that is the answer. Now, let's see if we can do number 3.
perhaps the mean is a position. We already talked about that. Actually, we did talk about that. The mean. Why I don't want to answer it because we have to finish the sentence right here to say, is the mean a position? Or we already kind of mentioned that in a previous sentence. What about the standard deviation? Is the standard deviation a position in the data set? Let's go ahead and fill these in. Again, we can work with our groups.
Just like I think it could be, but it's not.
Okay, excellent answers. What's the mean? We said the mean was a
Position, because we know where it is in the data set. Where is it in the data set? It's in the middle. Good.
Do we see anywhere where the standard deviation is? Standard deviation of 13? Is that a position in the data set? No.
So the standard deviation is not a position. So, circle not. So make sure to circle but here because,
The mean is a position, but the standard deviation is not a position. So, well, maybe the standard deviation can be related to position because the whole idea of this worksheet is to go over what is position. But maybe the standard deviation is related to position. So A, B, or C, when you're
confident about your answer, this will be our poll everywhere question. A, B, or C.
if you're not sure, take a guess. So far, it says one person is on.
There you go.
Okay, I'm gonna close the poll. I think most of us have responded. Let's see what the answer was. We're a little divided. Why are you changing your answers? C was actually, I believe, wait, no. My bad. A was the correct answer. Okay, let's explain why A was the correct answer. First of all, we already agreed that standard deviation is not position. So that you cross off B.
Because standard deviation is not position. Okay. How is the standard deviation related to position? Well, that's not what C is asking. C is what is standard deviation? That's not what the problem is asking. That's how is standard deviation related to position.
So C is not the, what I should have said is choose the best answer. I'm crossing off C. So A is really going to be the correct answer because
You can use it as a distance from one position to another. We saw, what was the standard deviation in the previous problem? Test 1. What was test 1 standard deviation? 13. So we can actually use that to take the position between one and another value. So that's what we're going to do. We're going to take the standard deviation and look at it as a distance between positions of values in the data set, which is answer choice A. So here we're going to go back to our test, I chose test 1 where we had the mean of 74 and a standard deviation of 13. And for questions 5 through 11, we're going to put all our answers on the number line. In number 5, it says what value in the data set has a position of 1 standard deviation above the mean. So basically, we're taking the mean and we're going to use the standard deviation as a distance to figure out what value has a position of 1 standard deviation above. So let's go ahead and see if we can label what that value is on the data set. Number 5. Again, we can discuss this in groups.
Yes, this one.
So what is
Standard deviation above.
So we're just we're going to use the standard deviation as a distance from the mean. So what was 1 standard deviation? Or what was the standard deviation?
Yeah.
1, 2, 3, 4, 6, 7. Okay. By 1 standard deviation above, we mean the distance from the mean to that value. The standard deviation is 13, so all we're going to do is going to count 13 after 74. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Is this value right there?
And that value is 87, because if we look at that, we see, ooh, that's not what I intended. If we count it up, we see 75, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5, 6, 7. So here we have 87. So the answer is 87. That would be
1 standard deviation above. And see, we're using the standard deviation as a distance from the mean, which is 74 to 87, which is 1 standard deviation above.
Now that tells us to draw the standard deviation. Let's go ahead and draw what we think our standard deviation looks like.
What was the standard deviation again? What does it say the standard deviation? It represents 13,
And we're using it as a, what does question 4 say? We're using it as a distance. So if it's a distance, if we're going to be drawing the standard deviation, it should look like a distance on the number line.
So let's go ahead and draw the standard deviation on the number line. Again, we can ask our partner for help. Okay, this is what it looks like. It's just a line going from 74 to 87 with a distance of 13. That's all I was asking for in the problem. Any questions so far? I haven't really given us an opportunity to ask questions. Okay, what about the position of 61? And again, we're using standard deviations here to describe position. So how can we describe the value 61? Okay, groups of 2. Very good.
One standard deviation below.
If we
Look at between 74 and 61, we're actually counting 13 down. So again, we've used the standard deviation to describe 61, but it's not 1 standard deviation above, it's 1 standard deviation below. Good, so 61 has 1 standard deviation below. Am I done writing here? Below what? The mean. You have to make sure to use the mean because otherwise, what is it below?
The mean is one standard deviation below 87, but 61 is one standard deviation below the mean. So we have to be very specific.
Okay, this question right here says, would you rather score 2 standard deviations above the mean or 2 standard deviations below the mean? I want some great explanations here.
I'm gonna go
What other cases for you?
Okay, above or below? Do we want to get 2 above? What's 2 standard deviations above the mean? It's 100 and 2 below would be in the 40s. So you don't want to be in the 40s. You want to be 100. So actually, you always want to be above the mean. You always want to be in terms of standard deviations above the mean or better than average. So I'm just going to write above. I want some great explanations on there though, like I'd rather get 100% than score in the 40s. Because that would be a very good test score. So make sure to write in great answers for that.
And then number 9 says to determine the test scores that are within 1 standard deviation of the mean. So first, what are those values? And then shade them
On the number line. So all of the values that are within 1 standard deviation of the mean. What do you say?
What did you write for number 9?
I said, I didn't write, I just shaded them in.
Okay, well that's both answers. Okay, both shading. So within one means no less than 1 below and no more than 1 above. So this is what the shading should have looked like. And we see that's 61 to 87. So that's going to be the answer. Any questions
On that, a lot of students get confused here because they think, oh, 61 to 87, well, that was 2 standard deviations. Well, there's a total distance of 2 standard deviations, that's true. But when we say within 1, that means 1 below and 1 above. So no less than 1 below and no more than 1 above. So that's what we mean within 1. Any questions on that?
Okay, now we have something called a z-score. The z-score describes the position of the value using standard deviations in relation to the mean. So in our groups of 2, let's hypothesize what we think a z-score of 87 would be.
It'd be a score.
Okay,
So the answer to 87 is going to be 1 because you added 1 standard deviation. So the z-score just tells you the number of standard deviations you added to the mean. We added 1 standard deviation to the mean, so the z-score is 1. See, we just added 1 over here to go from 74 to 87. So the correct answer again is positive 1.
Okay, quickly for number 11, what value has a z, or yeah,
Yes.
Oh, sorry, okay, I'm sorry, I'm really sorry.
It's okay, let's quickly fill in what our answer for 11 is.
so the answer to 11, yes, Anna, you were correct. When we have a z-score of -1, it means
Subtract one standard deviation from the mean, and we subtract one standard deviation to get to 61. So the answer is 61.
for this one.
It's totally fine to ask questions. You don't always, it doesn't always reveal what the answer is. So, what's 100? What's the z-score of 100? 2. So, good.
So what does he score like 105 be?
It would be above 2, but it would be 3.
So do you just round or do you do like a z-score of like 2.5?
There's a specific formula that we're going to learn in chapter 6 that gives us the precise speech value formula. Actually, you know what? Let me give it to you right now, just in case the homework asks for that. Okay, the z-score formula is you take your value, which we call x, and you subtract the mean, and then you divide by the standard deviation. Let's go ahead and verify that that worked for 100 when we subtract the mean and then divide by the standard deviation. What was the z-score of 100? 2. So we should get 2 if we do that. Let's go ahead and do that just to verify that the formula works, because
It was 74. That's 109.
yeah.
What's your favorite Friday?
So this ends up being 26 over 2, which is 13. So please be aware of this formula, because it's possible that I might have accidentally assigned a homework problem where you needed it, but I'm actually going to talk more about that formula in a later chapter. Now, this is my first time using Connect Math, so I do apologize for anything that I do, because I'm not 100% familiar with it. I wish we used my math lab, because that's my favorite. I said I was never going back to this. I didn't have control over the Connect Math thing.
Okay, here we have some scores here. This is a graph from the first test, and I actually now tell you the percentage of people that got like between 83 and 90. And we're saying what percent of values are within one standard deviation of the mean, or have a z-score between blank and blank. So go on and fill that in first, and then try to approximate the percentage of values within those two values.
I think this is
Z-score would be -1.
yeah, so it's 74. So the mean is 74% of values are
That's right.
Well, we know at most would be, at most would just be all of these ends up.
So within one standard deviation means between one standard deviation below, which we said was -1 z-score, and one standard deviation above, which is +1 z-score. Now, what was one standard deviation below? What was the value again?
61, which is like over here, and then the 1 standard deviation above was 87, which is like over here. So is that actually 100% possible to calculate? No, because we have to add all of these together, and we're gonna get a value that's over or under? Over, because we're adding some additional. So since we're getting a value that's over, whatever value we get has to be, what is it, at least, exactly, or at most? At most. Because it can't be bigger, because it's already bigger than what it's supposed to be. So, that gives us C, and then we simply just add all of these values together. So the 9.54 plus the 16.67 plus 23.81 plus 19.05 plus 11.90, and I believe it's 69.05%. So we're getting a value that's over. It shouldn't be anything more than 69.05%. It should be smaller than 69.05% because we're chopping off this thing and this thing. Yes.
Can you spell what you're doing again? I don't understand why you're adding.
Oh, because we're looking at the percentage of values that are between 61 and 87. So we know that there's 9.52% over here, 16.67% over here. So we're just going to add them together to get the total percent between these two values. But we're going to have to chop these two little sections off. So it's going to make a number smaller than 69.05. So that's what we said at most.
So you added the 9.52, 16.67, 20.81, and 19.05?
Yes.
Okay.
Oh, sorry.
Yeah, I just.
My bad. I shouldn't have put a plus here. Was that what you were going to ask, Anderson? Okay. Any additional questions? It's possible I might have missed something like I did last time. Okay, next we have something called the empirical rule and Chebyshev's theorem. And these, or we're actually going to call it Chebyshev's rule. And these things approximate the percentage of data within a certain amount of standard deviations. Like within 3 standard deviations, according to Chebyshev's theorem, has to be at least 88.9% of the data. Now, for the first part of this, we're simply going to take our 2 stray values, which are 75% and 99.7, and put them in the missing boxes here. So we see that it's going up because as you go within more standard deviations, you're covering more data. Within more standard deviations, it's more data. So the number should be going up. So in groups, should this be 75 or 99.7? The same thing with this one. Okay, it looks like, or yeah, question?
How do you find the straight percentages?
So it's going up because we see as you cover more standard deviations away from the mean, the data goes up. You're covering more and more data, so you're going up. So it goes from 68 to 95 to, is it 51? If it's going up.
Okay. Oh, yeah, I got it.
Okay, so that was a good question. What does this one have to be if, as you cover more standard deviations, the percent of data has to go up? Can this be 75 if the data is going up? No, this one has to be 99.7. And this one here, can this one be 99.7? This one has to be the biggest because within 3 standard deviation covers more data. You're adding and subtracting more standard deviations. You're covering more values. So this one has to be the 75%.
Now, it turns out we have a formula that helps us figure out these values for Chebyshev's rule. You just do 1 minus 1 over k squared. Let's go ahead and verify this formula works for 2 standard deviations. So plug 2 in for k and verify that you get 75%. I'm showing a lot of steps here. 4 over 4 minus 1 over 4 is 3 over 4. 3 over 4 is 0.75, which is 75%. So here, did you guys see how we got 75%? Good. We just do the 1 over 2 squared and such and such. Now, the empirical rule, you have to do it on Excel. We're going to do more of that stuff in like chapters 5 and 6. Now, it turns out that we can also apply the empirical rule or the Chebyshev rule to question 12, and we don't really know the exact data, so that's an instance of when we should be applying empirical rule or Chebyshev's rule. So let's go ahead and see if we can fill in these blanks for question 14. And we're referring to question 12 here, since it says question 12. So this is a long question. I would fill in the last sentence first. I would say the blank applies to the data set in question 12, and then do the bottom.
Chebyshev's rule?
Oh, because the first one
Well, it has to come from one of the words.
Yeah.
You can repeat the words. You can repeat the words. Okay, let's start filling in some of these blanks. How many of us went with the empirical rule for this one? Okay, it looks like most of us are nodding our heads for empirical rule. That's correct. Let's fill in the last sentence first. I think it's easier. So this is the empirical rule. Why did we choose the empirical rule? Because 69.5% of the data fell within 1 standard deviation, and that's closer to 68% than 0%. So if we were to have applied Chebyshev's rule, it would have said that at least 0% of the data falls within 1 standard deviation, but we got 69.05%, and that was way closer to the 68% than it was to 0%. So it makes sense that the empirical rule would be more applicable. Okay, now trying to fill in the rest of the data, because the blank is more applicable to blank data, and the blank is more applicable to blank data. If you look at here, what kind of data are we dealing with? Either skewed or symmetrical. Which one is the empirical rule going to apply more to? The symmetrical data or the skewed data? Okay, let's think about this. What's the higher value, the 68 or the 0? 68. Why are we getting a higher value? It's because more data is in the middle. What kind of distributions have more data in the middle? Symmetrical. So the empirical rule applies to symmetrical data because that's when you're going to have more stuff in the middle. You're going to have more data within one standard deviation of the mean. So this one was empirical rule. Although you could have written Chebyshev if your next blank was skewed, but we're going to start with empirical rule and then just say symmetrical. And then the Chebyshev's rule is more applicable to skewed data. Because with skewed data, all your data could be on the side. And if all your data is on the side, then you have like 0% of the data within one standard deviation. If you had it skewed and all the data was on the side. Now's a good chance to ask questions, because that was a harder question. Okay, 15. Here's a harder question. We were given a skewed distribution with a mean of 202 and a standard deviation of 41, and we're trying to find the percent of adults that have cholesterol between 38 and 366. So first, we have to figure out, should we be using the empirical rule or Chebyshev's rule, and then we have to figure out within how many standard deviations the 38 to 366 is, and I gave you a number line here so that we can figure out which one of these things to pick from the chart. So let's go ahead and use our groups. We're going to need our groups for this one. All right.
15 minutes.
Yeah.
Chebyshev. Yeah, skewed.
Oh.
How many standard deviations? 4 standard deviations. Yeah.
So it's 41.
Yeah.
Where did I put my
93.7%.
Okay, so this is skewed distribution. So we're using empirical or Chebyshev's? Chebyshev's, good. And then we have to figure out how many standard deviations are we dealing with. Well, if we add 41, the first number that we get above the 202 is 243. So it was definitely not one standard deviation. If we add a second standard deviation, 284. If we add a third standard deviation, it's 325. How many standard deviations did we have to add? 4. 1, 2, 3, 4. We added 4 standard deviations. Do we even need to check the bottom? Do we need to even check the bottom one? We should, just in case, because we don't want to jump to conclusions. So if we check the bottom, is that a question?
You can finish it.
Okay. So if we check the bottom, the numbers were, if you subtract 1 standard deviation, you get 161. 2 standard deviations, 120. 3 standard deviations, 79. And then 4 standard deviations, 38. Okay.
question?
Oh, she might understand it's a good one.
Okay.
How do you distinguish is the Chevy rule, the Imperial rule?
So Chebyshev is for skewed data because
Okay.
when you have more data on the side, less of them make.
So if
Make
this,
sure numbers go down.
if this was like, if we were just looking like 202, 366, would you use empirical or do you literally take all and just look for if it says it's a skewed distribution or a symmetrical
So
distribution?
that's a good question. If you had just from 202 to 366, you wouldn't be able to apply Chebyshev's rule because the Chebyshev's rule only applies to within 4 standard deviations or within 3 standard deviations. Or within 2 standard deviations. If we just look at 202 to 366, that's the 4 standard deviations above, but it's no longer the 4 standard deviations above. It's not symmetrical, which is why we can't take the percentage of value and divide it by. Oh, I see what you're saying.
Okay. So we don't know what the data set looks like. For all we know, the data set could be like, it could have a huge bar over here and it could have like little bars here and like no bars there, meaning that all the data falls over here.
We don't know what, or yes?
So if you don't know, then you use the chefs first. If you do know, then you just use which one works better.
If you know the exact data, you can do what we did before, we just add all the bars.
But if you don't, you have
If
to.
you don't know, then we have to choose Chebyshev's or empirical based on what we know, whether it's symmetrical or whether it's. Yes.
Oh, why we wouldn't put 8? It has to do with over here in this problem where we said within what position, or sorry, let's go over here. Determine the test scores that are within 1 standard deviation of the mean. The within 1 standard deviation meant no more than 1 above or no less than 1 below.
Even though that actually covers 2 standard deviations, it's still within. So same thing with within 4, it covers 8 standard deviations.
We didn't finish the problem. Okay, so we have the 4 here. So because we're using Chebyshev's rule, we have to apply this formula here. So I'm going to go ahead and do that. I'm going to take this formula, and what's our k? 4. So this right here is k, and we're using the 1 minus 1 over k squared, which is 1 minus 1 over 4 squared, 1 minus 1 over 16, which is 15 over 16. And when you divide 15 divided by 16, you get 0.9375 or 93.75%.
Okay, any questions on that? I think the homework doesn't even ask you for tables for it. So you could just steal the values off of your Okay, last chance to ask questions before we move on to percentile. Yes.
You just need one more time when you use.
So you use both of them if you have no idea what the data set looks like. In this case, we have no bars on top.
So because of that, we have no idea what our data set looks like. For all we know, it could have been like this. We have no idea. We're kind of guessing. So we have to either use Chebyshev or empirical. And Chebyshev works better for skewed, and empirical works better for symmetrical.
And how do you know if it is?
It has to say it in the problem. So
Okay.
this one just said that it was a skewed.
And if we look at this one here, which one did we use for number 12?
Did we use empirical rule or Chebyshev's theorem? Because this is actually much more symmetrical than it is skewed. So really you have to choose the one that looks best for this particular problem. So since this was much more symmetrical, so
Is it more symmetrical because it has like less standard deviations? Is that like a good way to like help understand it, or is that not? Because of the Chevy rule or whatever. it's called.
yes,
Yeah.
they do go together. They do go together. So because we see, I mean, really the best way to know that it's symmetrical is you look at the mean is 74, just like over here, and we see that it's kind of evenly spaced throughout the middle. And because of that, more of the data was in the middle, which led us to apply the empirical rule. Yes?
So I'm trying to look, so I'm trying to figure out, I'm confused in terms of like, is there like a different formula you use for each one? So I'm trying to like distinguish it more in my head. And I'm confused, I'm like, I understand using empirical rule when it's more symmetrical and more close and Chevy checks when you're more skewed spread out. Like,
Yes.
what is the rule exactly? Is it an equation? Is it just like?
So
I'm just confused.
this is the formula. What about this formula here? How do you feel about this formula? It's only for Chebyshev. The formula that you use for the empirical rule, we wouldn't have been able to do because we would have to use Excel. And we only know what it is for 1, 2, and 3. We don't know how to do it for 4. We were able to do it for 4 for the Chebyshevs because we have this beautiful formula here. But for the empirical rule, we didn't have any sort of formula for that.
Okay. Alright, I mean, I guess I was trying to like, when we have tests, are you gonna tell us if the data is symmetrical?
Yes, it should tell you what, it'll be straight from the homework, and I think the homework uses, I think actually, instead of symmetrical, they say bell-shaped, which is basically symmetrical. I thought symmetrical was a better word choice, but they'll probably say bell-shaped. And then you'll know, oh, I have to use which one, empirical or Chebyshev? Empirical rule, yes, good go. Because bell-shaped would be more symmetrical, which would be empirical. And then, like, no, we would use the Chebyshev. So actually, you could always use, what I want to point out here is you can actually always use Chebyshev's theorem. Why can we always use Chebyshev's theorem? Because Chebyshev's theorem says at least 0%. Is 68% at least 0%? Yeah, so you can actually always use Chebyshev's theorem.
So we don't even need to know what's happening.
Well, if it's symmetrical or bell-shaped, you're gonna get much better values. Do you really want to put 0% of the value, at least 0% of the value is, that's always true. At least 0% of the value is always within one standard deviation. It's gonna be at least 0%. You can't have less than 0%. You can't have less than 0% of the data. So this is not not an accurate statement. So if you can use empirical rule, use it. If you can't, go to Chebyshev's. The only time you use empirical rule is if it's symmetrical or bell-shaped, have lots of data in the middle. Anytime you have skewed or weird-looking things, use Chebyshev's. Or if you have absolutely no idea, then use Chebyshev's as well, because you don't need any criteria for Chebyshev's, because it says at least. Okay, I don't know if I answered all the questions, but I think like as we kind of think about it a little bit, do the homework, things will start to make a little bit more sense, and then we can check in on Thursday if we're still a little hesitant about any information.
Okay, so now moving on to, it's really hot in here. Okay. Question 16. Okay, so
For question 16 to 24, I gave you the raw data from the first exam, and I want you to rate the person that had a z-score of 1. So first we have to figure out what was the value that had a z-score of 1 again, remember from a previous problem, and then rank it. So let's go ahead and rank it. Groups of 2.
So it's 84, right?
Yeah.
And so the person who has Z-score of 1 would get 84, but
So the z-score of 1 was, oh, you're right. The z-score of 1 was, I was a typo on this. My bad. This should actually be, no. I was right. Never mind. Sorry.
It's fine. Okay, what was the value that had a z-score of 1 again? 84.
Where's 84? It's over here. My bad. I did not mean to do that. I meant to do this. Okay. 84 is over. Okay, I see what the problem is. Okay. I did have a typo. This is supposed to be -1. This is supposed to be -1. Okay, let's redo the problem with a -1 here.
It's easier to do it if it's a -1. The problem with doing it as 1 is if there's 3 values in the set.
they're true to their 58.
What 61 was the z-score?
Okay, hold on. Let's go back here. The z-score of -1 was 61, wasn't it?
Our mean is 71 now, not 74.
The first oh, you're right. Oh, I see.
We could just like change one of these 58s to a 57 and call it
Okay,
a day.
just change this to a 74.
Change this to a 74.
Wait, let's say in the instance that we give us this problem with like the 71 and or even
So
never
in
give
that
us
case,
that.
it doesn't matter, you can use any of them, but I was just trying to pick one that had a more simple.
Or it doesn't matter.
It doesn't matter. It's just simpler.
There's no 74 on the number index.
Okay, this has to be 74 because if we look at the, remember the 74 and the 13 go together.
The 74 and the 13 go together. I made a mistake. I shouldn't have put 71. I should have put 74. That's okay, because we were looking for the z-score of, what was the z-score? Z-score of -1.
What was the, I changed it. Okay, look,
-1. I changed it to a -1 here.
There's no 74 on the.
74 is just a mean.
Okay, if we have a z-score of -1, we subtract 13 from 74. What happens if we subtract 13 from 74? 61.
so do it with 61. Okay,
Let's quickly finish this. I'm coming around to finish all our, or to clarify. So I changed that to
See,
So you see if we rank, it's, there's 17 in the first row, and then 18, 19.
okay, so let's see, what's the rank of,
61. Well, there's 17 in the first row, so this is ranked 17. 18, 19, 20, 21. So we're gonna put 21
at the top.
because it's the 21st. It's the 21st value out of how many total? 81. So it's the 21st value out of 81 total.
And if you divide 21 divided by 81, you end up with 25.9%.
And because it's 25.9%, that's the same thing as 25.9 out of 100. This will make more sense in a second.
25.9 out of 100. The definition of a percent is out of 100. When you say 60%, you mean 60 out of 100. Percent always means out of 100. So 25.9% means 25.9 out of 100. Yes.
Say you have like 361s, so you would do like each one a separate rank.
So
You get 3%?
you get to choose which one you want to do. So you could have 3 different rankings for 60, or 360.
And then you would just write all 3% or just choose one?
You get to choose the one you want depending on what the book asks for. We're going to actually simplify it by choosing a formula so that we get the same number each time. We haven't gotten to that part of it yet, to kind of compromise so we don't have that issue. Okay, any questions on how I got the 25.9%? That's called a, well, I want everyone to write down what the percentile is.
For number 17.
Okay, groups of 2, what's the percentile? The percentile just means if you convert it to out of 100 or you convert it to a percent, it's just the 25.9.
So you don't.
So the answer is just 25.9th percentile.
Okay, both percentiles and z-scores tell you the position in a data set. I want everyone to move each of these boxes to advantages and disadvantages.
What's the advantage?
Actually, yeah, it's easier to understand.
Okay, which is easier to understand, the z-score or the percentile?
Z-score.
Oh, no, percentile.
Really?
Subjective.
It is okay. If you tell someone,
Oh, I scored in the 90th percentile, and then you told somebody else, oh, I had a z-score of 2. What are they more likely to understand?
I thought you meant just generally like in terms of this class. You know
Okay.
what, you got your problem.
I feel like maybe our answers are a little biased because I had a mistake on the percentile problem. Maybe that could be why.
but I'm just saying, if in general, if you were to say like I scored in the 90th percentile, people are gonna know what you mean. If you said I have a z-score of 2, are people gonna know what you mean?
No.
Not really.
So percentile, I would say, is easier to understand, although you're right, it's subjective. And then this one's harder to understand. Okay, which means, however,
For the percentile, what do we have to know? Yeah.
sorry. My bad. It's like you make one mistake and then the whole problem is off. Harder to understand. Okay, okay, what about the other two?
Which of them do we have to know the number of values? what are the only two things we have to know for z-score? Mean and standard deviation. There are actually many different ways of finding mean and standard deviation. We're going to find out how to even approximate those when you don't even know the number of values in the data set. But for the percentile, did you have to know the number of values in the data set? What were they in the last one? 81, did we have to know that? Yes, you have to know the number of values in the data set for the
Percentile. So, number of values in the data set must be known for the percentile. That's a disadvantage because you have to know the number of people that are in the data set. But for the z-score, you don't have to know that. You can just know the
standard deviation and mean, and somebody may have already calculated those for you, and you can figure them out. You don't have to count the number of people and then look at the rank. Any questions? We're almost there. We're getting there. Okay. What's the definition of the percentile in the context of the data set? It's the blank of students who scored blank of 61 on the test. The percentile was 25.9, and that's a... Okay, what is this? Is this the amount of students, or is it the percent of students? Good, the 25.9 was a percent. It's the percent
of students who scored.
How many? Only one student scored exactly a 61, so we need. Good, at or below 61, because we included 61. We counted 61. We looked at its rank. It was, what was the rank of?
61. It was 21. So we included the 21. We did 17, 18, 19, 20. That was 20 below, and then 1 at 61. So 21 total. So we have at or below. But it turns out that the definition of the percentile can also be the students who scored below a 61. And that actually helps you deal with the problem where if there's multiple 61s, it's like, oh, which one do you choose? Well, just look at the ones below 61 and just ignore 61 altogether. So let's do that number. Let's now do number 20, where we're using the definition of the percentile to be who scored below a 61 as opposed to at or below a 61.
You teaching a fish method?
You just or the individual that scored below.
Now it's just scored below.
This time. Yeah. That's why you say I'll be all things. And then in third grade.
Okay, so how many students scored below a 61? It's 20 now. It's not 21 because we see that there are 20. We're now excluding the 21s, or we're now excluding the 20. We're excluding the 61. So if we count them, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So 20 divided by 81, and that gives us 0.247, or 24.7%. So the answer is the 24.7 percentile. Okay, now one last definition of percentile is to average the two percentiles together, which is the 24.7 and the What was the first one? 25.9. Let's average those together and see what number we get. And this is the definition that Connect Math uses, but they actually use this little cheat cut formula where you do this instead for the percentile. You look at the number of values less than, in this case, 61, add 0.5, and then divide by the total number of values. Let's go ahead and use that last formula to see if we get the same thing. Number 21. You get the same thing. We're gonna get different values.
Yeah. Good job, folks. Good job. Oh, how's your first semester going? Or second semester?
Did you put in?
Let me see. So it's 20.5.
But let's do the same one as we did before. As if, like, let's just do the first one you want after.
You just want to do the number of values less than X, not less than.
Okay. So what is the number of values less than 61? 20. So the number of values less than X is 20. So we have 100 times 20 plus 0.5 over 81. When we do that, we get the same number, 25.3.
Yes. Okay. This is connect, I want to say this because we're all going to be doing the homework. Connect Math uses this formula for the percentile, but it is the average of both the previous definitions of percentile. Because it's like where did Connect Math get this formula from? But all it is it's averaging the two definitions of the percentile. One where you include the value and one where you exclude the value. Just do the way we did it. Just yes.
So this would give you the percentile.
Okay, so it's saying that there's.
You kind of go, because it's like, if you're saying if they scored below 61, then it's high.
So it's not the percentage of people that scored below 61, and it's not the percentage of people that scored at or below 61. It's the average of this. It's a compromise because we can't make up our mind which one we want to do.
So is this mainly for when there's like multiple values, like so if there's 360, because we can't.
Exactly. Therefore, we can just use this formula and we get the same thing every time. And we don't
Instead of like having three.
Exactly. So it looks like we didn't quite finish the worksheet, so I'm gonna have to add an additional video to the homework. But see if you can finish the worksheet on your own using the additional video.